Yes, again, good morning. So thanks, Paul, for introducing me for the second time. Hopefully, I know these transparencies or these slides better than the previous ones. So the thing I want to speak this morning is the GenComm pilot plant. It's a solar-powered hydrogen refueling station. It's a more or less non-public station we will build within the GenComm project. First of all, a small agenda. I want to say some words about the Department of Technical Innovations. I'm the leader of this department, and we have several mobility, or not really mobility projects. It's more infrastructural projects for alternative mobility. Then, short note to the GenComm project. Paul already said many things about the entire project. And then I will give you an overview of the status of the solar-powered hydrogen refueling station, which will be located in the Innovation Campus of Saarland, in which also the headquarters of IZES is located. And then 2 slides about outlook and some conclusions. First of all, the Department of Technical Innovations, what we are doing is we have planning and development and construction, and also the operation of innovative infrastructure for alternative mobility concepts. And here it is especially for battery and for fuel cell electric vehicles. And for battery electric vehicles, we have one current project. It's a follow-up project of a project which was called OptiCharge. And we see that some things could be made better. So the goal of OptiCharge Plus, the follow-up project, is to increase the efficiency of the OptiCharge charging station. In particular, we want to optimize the functional materials of a vanadium redox flow battery as an energy storage on-site. Then we want to optimize or to improve the energy management system of the whole plant, and the new hardware. We want to set up a DC microgrid for DC loading, and we want to connect the entire charging station to the Internet of Things. These are the points we have, and now I give you a dia show or some pictures that you know from what we are talking. This is the building area, more or less at the beginning. Here you can see we build up the main part of the carport for 4 vehicles, and the battery container is flying in. This is a battery, a vanadium redox flow battery with 30 kW power output and 120 kilowatt hours of storage. Here you can see the plant or the loading station at the present status. You can see the carport. It is more or less 14 meters long and 5 meters. And here you can see the PV panel, which loads on sunny days the vanadium redox flow battery. The PV array has a peak power of more or less 10 kW. GenComm project, an overview. Paul already gave this at the beginning of the webinar today. He said that we have free implementation or free investment work packages with different sizes, 25, 100, and 500 kW electrolyzers. And the supply of these electrolyzers is one-time solar, bio, and wind energy. So the IZES plant is the smallest. It's it's operated with solar power, and it's for mobility purposes. We have to construct and to operate the solar-powered HRS during the project period. So it is located, as I said before, also in near the headquarters of IZES. We use solar energy. The hydrogen production will be from 2 electrolyzers, one AAM and one PEM electrolyzer, and the maximum H2 production of this plant will be more or less 5 norm cubic meters per hour. The gas quality should be 5.0. We have storage on site of more or less 60 kilograms of hydrogen on 2 different pressure levels, one 450 and one 950 bar. We have a containerized solution within 2 20-feet containers, and we operate the station as a non-public refueling station. This is a schematic diagram of the blend hydrogen refueling station as we start in the early 2017. It's more than 3 years ago. You see the 2 20-feet container fence around it and separated dispenser. This is the solar panels, or the minor part of the PV array. The other part is on the roof in the east. This is the west roof, or direction of this roof you can see is west, and the main part is on the eastern roof. You can see some difficulties we have. This is we find some pipes, some cables, some things were not planned, and there are no plans in which they are reminded. And you can see the cages for the foundations for the 2 containers. And this is the area at present. We have a fire protection wall against fire of the car, and this is the plant which is at present at the manufacturer in Scotland, and you can see the plant from the other side. It's with the separated dispenser in front of the picture. And one picture again. This is the location of the 2 facilities we have at IZES. One, the OptiCharge station, you can see on the left-hand side, and the red and white striped circle. This is the place of the hydrogen refueling station, and also you can see the PV panels also on the right side, and the headquarter of IZES. These are short summary of the work we have done in the GenComm project, and an outlook. What will the next steps? We will finalize and the delivery of the hydrogen refueling station should be end of this year. The civil works should be also completed end of this year. It is mainly to build the fence. And the operating permit for the refueling station is expected for mid of the first quarter of 21. And one conclusion, also a short one, we think, and I think the whole GenComm community or family said, hydrogen has the potential to decarbonize the transport sector sustainably, but not only the transport sector. There are many more sectors which can be decarbonized if you use green hydrogen. That was my presentation, and thank you for listening.
Dr. Gros, thank you very much indeed. We have a number of different questions, but I'll lead off with one for you. I know the answer to this because we're working very closely with you, but our audience is up on 145 today. Can I ask a simple question? It might seem simple, and hopefully it will explain to the audience, who are, by the way, gathered all the way from, just looking at the polls here, from Perth in Australia, the whole way right through to America. So we have a worldwide audience looking at your solar station in Saarbrücken. Why 2 electrolyzers, Bodo, please?
Okay, that's a good question. So we are a research institute, and the proton exchange membrane electrolyzers are more or less a common product, and we said, okay, we want to have also a AEM to look how the technique works, and is this a technology for the future. So we want to see how these two electrolyzers work together, and the AEM is a smaller one with 1 cubic meter per hour. So we can operate this smaller unit more or less the whole time with the solar energy coming from the roof. And if it is necessary, we can also use or we can also operate the PEM.
Excellent.
Yeah.
Okay, thank you. There's a question also, Bodo, from Tim Noon. And Tim, I don't know where you're from, so apologies. Says, Bodo, great presentation. And he asked, what water quality is required for the electrolyzers? Is there a need for separate treatment of the potable water supply?
Yes. There is a reverse osmosis in downstream.
For both electrolyzers?
Yes, of course, for both electrolyzers.
Another question here, and you like this one, Bodo, it's non-technical. How has COVID affected the deployment of the station?
Yes, COVID has, the manufacturer is from Scotland, and the UK has a lockdown long time, so it affected it. But it is difficult to say that COVID is the only reason that there's a no, it's not only COVID. There are some other reasons the electrolyzer is not there at present, but yes, concerning the lockdown, it concerns the delivery of the electrolyzer and the whole plant.
I think what the question is getting at, we all live in this new world, and project plans and delays have all impacted everybody. But what the question is trying to get at is, it's back on track, Sean, to answer your question, and that both the big investment packages with Energia and with IZES are working to get work around the different problems and the delays caused, because it's caused across globally, and we're working around that, but we're overcoming those difficulties. Question from Porrig O'Hara, originally a Cork man, I know, near living in Dundalk with Louth County Council. And Porrig asks you, Bodo, is he right in understanding the peak power from your solar array 30 kilowatts?
Yes.
Right. Yeah.
Yes, the peak power is 30 kilowatts.
And Dara Kine asked, this was a fine question before we move on to the next speaker. Dara Kine asks, has the project looked at the possibility of scaling up the refueling station? And if so, what have you identified as the constraints? Have you identified on-site H2 production, if any?
No. You see, we are a research institute, and this is the reason we cannot operate the refueling station as a public one, and this is also the reason we will not go to a bigger one. And that's the point. We want to make research on the station, and that's the reason we built this station in this small size.
Excellent. Dara, to answer your question, the three pilots within GenComm are about demonstrating the scale, the size, and the opportunity for use of the hydrogen. Our next step, and the reason for the HAZEL project, the Hydrogen Zero Enabled Supply Chains, is looking at opportunities beyond that, and now linking in through the Green Deal or in through the innovation calls that are coming out. And how, with our associate partners throughout GenComm, such as Belfast City Council, Louth County Council, all of the other public authorities, including the federal state of Saarland, is how we take these pilots and in collaboration with other partners, now scale them up in different areas and in different regions and for different opportunities. And that is the next step in the process. Dr. Gros, many thanks for your opportunity and for speaking and for giving us that outline on the work. One other thing we forgot to mention, in the first pilot, which is up and running already in Stornoway, led by Pure Energy Centre, they have developed the biodihydrogen and that closed circle. So if you look at the GenComm website and have a look at the pilots, you'll see the studies already there for the Stornoway site on the Pure Energy system, or Pure Energy Centre, looking at that bio. Bodo, thank you very much indeed.